In these slides, I'm going to present the standard equation of an ellipse and then sketch an ellipse when it is centered around the origin and when it is shifted. Remember that an ellipse is obtained as an intersection between a right cone and the plane that's oblique to the axis of symmetry of this cone. Knowing how to draw an ellipse will help us understand its definition. First of all, we can fix two nails and then extend the string around these two nails, and with a pencil we can stretch this string to draw the ellipse. These 2 points are called the foci of the ellipse, which is the plural of focus. Also, it can be seen that the length of this string is fixed, it does not change, so for any point on the ellipse P, its sum of distances d1 plus d2 to these 2 points is constant, and this gives us the definition of the ellipse. When deriving the equations of conic sections, we usually take the coordinate axes at their axes of symmetry. In our case, we place the two foci on the x-axis. The center is in the midway between the two foci. Accordingly, the center is the origin. The two foci are c units away from the center, so their coordinates will be c and 0 and negative c and 0. The largest diagonal in the ellipse is called its major axis. The smallest diagonal in the ellipse is called its minor axis. The minor axis is perpendicular to the major axis. Also, the ellipse cuts its major axis in 2 points. These points are called the vertices, and if we assume that this length is 2a, then the vertices coordinates will be a and 0 and negative a and 0. It's clear that the center, the two foci, and the vertices all lie on the major axis of the ellipse. Now we are ready to start our derivation. For any point P on the ellipse, its sum of distances to the two foci is constant, so Pf1 plus Pf2 is equal to a constant. We'll apply this same definition on the vertex. The sum of distances of the vertex to the two foci is also constant, so V1F1 plus V1F2 is equal to a constant. From the symmetry of the shape, V1F1 is equal to V2F2, so this total length is 2a. Accordingly, the constant is equal to 2a. So Pf1 plus Pf2 is also equal to 2a. Now we'll use the distance formula to find the distances between P and F1 and to find the distance between P and F2. So it will be the square root of x minus c all squared plus y minus 0 all squared plus the distance of Pf2, which is the square root of x plus c all squared plus y minus 0 all squared, is equal to 2a. We'll perform a series of algebraic steps to reach this equation. All the details will be found at the end of these slides. To conclude the derivation, we need to find the relation between a, b, and c. If we take P at the endpoint of the minor axis, so its sum of distances to the two foci will be equal to 2a. Since Pf1 is equal to Pf2, then Pf2 is equal to a. Now we can draw this right angle triangle where its hypotenuse is a, its height is b, and its base is c. So a squared would be equal to b squared plus c squared. We can rewrite it as b squared is equal to a squared minus c squared and use this to substitute in the equation of the ellipse. Accordingly, the equation of the ellipse will be x squared over a squared plus y squared over b squared equal 1, where the a is greater than b. This is the equation of an ellipse with a horizontal major axis. To summarize, the equation of an ellipse with the horizontal major axis will be given by x squared over a squared plus y squared over b squared is equal to 1, where a is greater than b. The major axis is horizontal. The center is the origin. The two foci and the two vertices lie on the major axis. C C is the distance from the center to the focus. A is the distance from the center to the vertex. So the vertices coordinates will be A and 0, negative A and 0, and the foci will be given by C and 0, negative C and 0, where we can get the C from this equation as A squared is equal to B squared plus C squared. What if the ellipse has a vertical measure axis? In this case, the center, the two foci, and the two vertices lie on the vertical measure axis. The minor axis is a horizontal line, and the equation of the ellipse, we'll see that the number under the y square is the bigger number, whereas the number under the x square is the smaller number, as A is greater than B. The relation between A, B, and C can be established through drawing this triangle. By joining the endpoint of the minor axis with the focus, the length of this line is A, the base is B, and the height is C. So A square is equal to B square plus C square. The center will be 0 and 0. The vertices, we can get them by putting x is equal to 0. We'll get y is equal to plus or minus A. For the foci, they are 0 and C and 0 and negative C since they lie on the y-axis. Now let's sketch this ellipse. This ellipse is not in a standard form. There is a 400 in the right hand side. So first we have to divide by this 400 to get a 1 in the right hand side. Accordingly, this equation will be x squared over 16 plus y squared over 25 is equal to 1. The bigger number is the 25, the smaller number is the 16, so A squared is equal to 25, which is the bigger number. B squared is equal to 16, which is the smaller number. So A is equal to 5 and B is equal to 4. This equation is in a standard form, so it's the equation of an ellipse that's centered at the origin. Also, the number under the y square is bigger than the number under the x square, so it has a vertical measure axis with the center at the origin. The two vertices lie on the vertical axis, so their x coordinate will be 0 and A and 0 and negative A. So they will be 0 and 5 and 0 and negative 5. To calculate C, we draw this right angle triangle where its hypotenuse joins the focus with the endpoint of the minor axis. Its base is B and C is the height. So A squared is equal to B squared plus C squared, and we substitute with the 5 and 4 in this equation to get C is equal to 3, and the two foci will be at 0 and C and 0 and negative C. They will be located at 0 and 3 and 0 and negative 3. Finally, to get the intersection with the minor axis, these 2 points lie on the x-axis. Their coordinates will be B and 0 and negative B and 0, which is 4 and 0 and negative 4 and 0. Another example, we are given here the foci of an ellipse located at 5 and 0 and negative 5 and 0, and the length of its major axis equal to 16, and it's required to find the equation of this ellipse. First of all, we have to start plotting the information we have. So we start by plotting the 5 and 0 and negative 5 and 0. It can be seen that the foci are symmetric around the origin, so the ellipse is centered around the origin and the center is 0 and 0. The major axis of this ellipse is horizontal, since the two foci and the center lie on the horizontal axis. So the ellipse can be plotted like this. Its equation is a standard form equation, x squared over A squared, the number under the x squared is the bigger number, plus y squared over B squared equals 1, where B is its minor axis, and it's the smaller number. To find the B and A, first the length of its major axis is 16, so 2A is equal to 16, accordingly A is equal to 8. Next, we draw this triangle, the right angle triangle, where its hypotenuse joins the endpoint of its minor axis and the foci, one of its foci. So the hypotenuse is A, the height is B, and the base is C. A squared is equal to B squared plus C squared. so we can get the b. B squared will be equal to 64 minus 25 is equal to 39, and then we can rewrite this equation by substituting for A and B. What about the equations of shifted ellipses? If you look at this equation, this is the equation of a standard ellipse where A is greater than B, so it has a horizontal measure axis. If the center of this ellipse is shifted to h and k, then each x will be replaced by x minus h and each y will be replaced by y minus k. And the new ellipse will have a center at h and k, and still it will have a horizontal measure axis. And similarly for the other one. Next, let's move on to this example where it's required to sketch this ellipse showing its center, foci, and the endpoints of its major and minor axes. It's clear that this equation is not in a standard form, and we have to put it in one of these two forms. These are the forms of shifted ellipses where we can see that the x minus h or the y minus k appear as perfect squares. Also, the coefficient of x and the coefficient of y in these brackets is 1. So we'll start by making a complete perfect square with respect to x and with respect to y. We'll make it twice. To make a perfect square with respect to x, we have first to factor out the 4. It will be 4 multiplied by x squared minus 2x plus y squared minus 4y. And take the 4 to the left-hand side, to the right-hand side, it will be equal to a negative 4. Then we'll complete the square with respect to x. It will be x minus 1. 1 is half the coefficient of x, and then we'll subtract 1 squared. Also for this bracket, it will be y minus 2, where 2 is half the coefficient of y, and we subtract 2 squared, which is equal to 4. Then we'll distribute the 4 over this bracket. It will be 4 multiplied by x minus 1 all squared minus 4 plus y minus 2 all squared minus 4. Then we'll move all the numbers to the right-hand side. They will add up to 4. Finally, we'll divide by 4 to have an equation like this, which is a standard form equation that's shifted to 1 and 2. So this is an ellipse that has a center 1 and 2. And if we look at the numbers below the y squared and below the x squared terms, the number below the y minus 2 squared is 4, which is the bigger number, which means that this is an ellipse that has a vertical measure axis. Also, its center is 1 and 2. It's really important always to sketch the information that we have. We can see also that the 4, this is the bigger number, is a squared, which is 4, so a is equal to 2. The 1 is the smaller number, so b squared is equal to 1, giving b equal to 1. This is the information that we have so far. You have an ellipse that's centered at 1 and 2, and it has a vertical measure axis. All the other requirements will be calculated using this sketch. That's why always remember to sketch what you have. Going from the center, A units upwards and downwards, we'll get the two vertices. Moving to the right and to the left B units, we'll get the minor axis. Moving upwards and downwards C units, we'll get the two foci. To calculate C, we only have A and B, and we need to calculate C. We can draw this right angle triangle, where the height is C, the base is B, and the hypotenuse is A, where the hypotenuse is the line joining one of the two foci with one endpoint of the minor axis. So A squared is equal to B squared plus C squared, where C will be equal to root 3. We have the center at 1 and 2. The major axis is vertical. What we can see is that the center, the two foci, and the two vertices all lie on the same vertical line, so all of them have the same x coordinate, which is 1. To calculate the y coordinate of the two vertices, they can be calculated as 2 plus a and 2 minus a. As for the two vertices, they also have the same x coordinate, which is 1, and their y coordinates will be calculated as 2 plus c and 2 minus C units. The minor axis is horizontal. The endpoints of the minor axis and the center all lie on the same horizontal line. They all have the same y coordinate, which is 2. They only differ in their x coordinate. The x coordinates of the endpoints of the minor axis will be 1 plus b and 1 minus b. These are extra problems that you can try if you wish. At the end of the slides, you will find the algebraic steps that we went through to draw an ellipse with a horizontal measure axis. If anyone is interested, you can just go and read this proof.